and for the possibility to share my work today. What I'm going to present today is a brief overview on what is currently being done about the waste management from new energy materials, specifically focusing on wind energy. Climate change and environmental degradation has driven Europe, but in general the global community, to adopt sustainable approaches. For example, Europe has recently introduced a new growth strategy called the European Green Deal, which aims to transform our economy into a modern and climate-neutral system that uses the resources in an efficient way and operates within a circular framework. Wind energy plays a crucial role into the European Green Deal and especially into the energy transition to achieve the climate neutrality. For example, just to give you an idea, it is expected that the wind power capacity in Europe will grow more and more each year. But as this transformation takes place, it will require significant material resources, and at the same time, new form of waste will be generated. When considering the production of waste associated with wind energy, currently it is relatively limited since these installations are still rather new, since they have an operating time between 20 to 30 years. But it is expected that the waste generation in this sector will significantly increase in the next years. And of course, this will be a huge problem to deal with. What about the recycling of the wind turbine? The good news is that up to 90% of a wind turbine can be recycled, but what really represents a challenge are the blades. In fact, those are made of glass and or carbon fibers and composite materials for which the recycling infrastructure is still under development. In addition to this problem, the composition of the blades changes significantly considering the manufacturer and the type of blades. So these differences means that we don't have, there won't be just one method to recycle this blade, but it has to be adapted considering to the kind of blade that we are considering. Currently, wind turbine blades at the end of their working life are often sent to landfill for disposal. However, luckily, several ways of recycling are currently under evaluation, such as mechanical and thermal and chemical processes. Now that I hope I made it clear why this topic is important and how researchers are dealing with it, I wanted also to emphasize how the interest into this field is increasing over the last year. In fact, between 2005 and 2015, more or less, the studies on this topic were relatively limited, probably due to the low awareness of the problem and also the recycling technologies for wind blades. But over the last years, there was an increasing interest into the recycling on wind turbine blade, which is likely driven by the increased environmental concern on this topic, but also the advancement into the recycling technologies and also the need to find sustainable approaches for the waste management in this field. Okay, it's good, the interest is increasing over the year, but the point is, till now, this topic has never been explored from the analytical point of view. But in order to identify the best way to recycle these blades, it's necessary to characterize the product that we obtained after these processes in order to recover these blades as efficiently as possible. So, with the ambitious goal on contributing into the evaluation of this different recycling method, we investigated wind turbine blades which were subjected to two different recycling processes, solvolysis and pyrolysis. We, for both these processes, dedicated sample preparation approaches need to be developed, followed by the detailed characterization on the product obtained, with the aim to better understand the recovering of high valuable chemicals, and also at the same time address some compound that may cause problem during the recycling process itself. So during this presentation, I would first focus on the solvolysis process, while in the second part, I will focus more into the pyrolysis oil obtained from the wind turbine blade. Among the chemical processes that I previously mentioned, the solvolysis is gaining attention. This process involves the use of chemicals to break down the polymer matrix into monomers and oligomers, resulting into the recovery of high-quality recycled fibers, which have mechanical properties more or less comparable to the virgin one. So we wanted to explore from the analytical point of view wind turbine blade which were cut in lab scale samples and subjected to solvolysis process. These samples were provided by Total Energies, and as a result from this process we received a liquid and a solid phase. So as you can see from the photo, we received this sample which were non-homogeneous at all, and that was not possible to treat directly as we received from the solvolysis process due to the condition of the process itself. So we decided to start with a neutralization step to treat the sample because of the highly basic pH of this solvolysis soup. Then, considering the well-known ability of the microwave to act as a heating source, and especially considering also the spreading of this energy-based extraction system, especially in this field, we decided to perform a microwave-assisted extraction using a mixture of two different solvents of a different polarity, which were hexane and methanol, in the ratio 10:3, with the parameter here reported. Then water has been added into the ratio 2.5, followed by a centrifugation step for 20 minutes. And the upper organic phase have been collected and concentrated to a final volume of 1.5 ml. These organic phases have been analyzed using a comprehensive gas chromatography coupled with the time of flight mass spectrometry, which was equipped with a non-polar column into the first dimension and a medium polar into the second dimension, with the parameter that here reported. This my GC methodology enabled us the identification of approximately 120 molecules, and for the identification we took into account the MS similarity, the use of the linear retention index into the range plus minus 20, and also the location into the 2D GC plot. Even if it looks like it's not a complicated, complex chromatogram, this first exploratory analysis allowed us to understand what we were dealing with. These identified analytes belong to different chemical classes, such as aromatic, which is an interesting class of compound since those can be valorized after the recycling process, as well as some heteroatom containing compounds, such as oxygen and nitrogen containing compound, that on the other side, if those are present at high concentration, may cause problems during the recycling process, such as problems of corrosion or poison the catalytic processes which are needed to obtain the final upgraded product. We also tested the repeatability of the method by performing the microwave-assisted extraction in triplicate, and then for each the GC-GC analysis in triplicate. So we obtained 9 analyses for each sample, obtaining for the majority of the identified analytes a coefficient of variation which was lower than 15%. We also performed an ANOVA with using a strict significance level of 0.01, and as you can see in the plot, in which you can find all the identified analytes and their corresponding p-value into the negative logarithmic scale, we observed that for both the liquid phase and the solid phase, only approximately the 10% of the identified analytes were statistically different among the replicates. In parallel, the product obtained after the pyrolysis of wind turbine blade were investigated. Basically, the pyrolysis is considered one of the most mature method to recycle the wind blades, which consists into the breaking down the polymer matrix with high temperature in the absence of oxygen. The point is that this pyrolysis oil was a complex sample to deal with due to the acidic pH, also because it was unstable over time, mainly due to its composition. And normally, when dealing with this kind of sample, some pre-treatment are needed. So in this part of the project, our goal was to develop a fractionation procedure with the SPE, so the solid phase extraction, in order to simplify these complex samples into different chemical classes. On the basis on what we found into the literature and also on the basis of a method that we previously applied for different samples, we decided to test 3 different solid phase cartridges, commercial one, and 3 fractionation protocols. These fractions then have been sent to Total Energies for further investigation, among which the elemental analysis. On the basis of the results of this elemental analysis, we saw that using a silica cartridge with eluting solvent of increasing polarity, it was possible to isolate all the nitrogen species, which were the one that we took into account for the fractionation, for the development of the fractionation procedure. We were able to separate them just in one fraction. So that's why for the next experiment, we opted for the silica cartridge. These fractions have been analyzed by GC-TOFMS using a reverse set of column and by GC-QMS with a normal set, with the parameter that I here reported. What we obtained was a first fraction, which was primarily composed of hydrocarbons, mostly aromatic compound, but also unsaturated and saturated hydrocarbon. While in the second fraction was enriched with oxygen, mainly oxygen, and nitrogen compound, as well as some aromatic compound. As I previously explained, the presence of these heteroatomic species can cause problems during the recycling process. So the successful separation of this fraction highlights the importance of the pretreatment method when dealing with these samples. In conclusion, in this work we obtained a preliminary characterization of the waste materials, emphasizing the important role that the sample preparation has in this field. This characterization not only allows for the valorization of the product obtained after the recycling on wind turbine blade, but also aligns with the goal of the European Green Deal by contributing to the concept of the circular economy. Before concluding, let's move to the important part of the presentation. I would like to remind you of 2 events that will take place in the coming months. The first one is the Advancing Separation Sciences workshop, the 3rd edition, which will be held in Jean-Blot in June, as well as the 1st edition of the Transition Analytics for Decarbonization conference, which will be held in October in Paris. With now I finished, I'd like to thank the amazing people I have the chance to work with, and of course you for the attention.